Hello viewers, welcome to All Force e-learning program, a unique program to enlighten and enrich you with the fundamentals and basic concepts of all subjects, which will be helpful for you for various entrance examination you go on for. I am DNR, D. Nagendra Rao, teaching physics since 1988. I have got 30 years of experience. This is my 31st year of teaching career. So I am here to teach physics. I warmly welcome you all into the world of All Force. You know, in All Force, it is our passion to enlighten young minds. You know, our passion leads to your success. So our passion is your success. Come on, welcome you all to All Force. Now, coming to the subject, you know, physics, it is a basic category of natural science. You know, science is to know, science is knowledge. Science is the systematic and organized knowledge of the natural phenomena, right? Out of various types of science, physics is a category of natural science. You know, physics has come out from a Greek word called physis, means nature. You know, this word was introduced by the great scientist Aristotle. Physis in Greek means nature. So physics is study of nature. Actually, physics is it is a study of basic laws of nature and manifestation of all the natural phenomena. You know, to be very specific, physics is the quantitative science based on measurement. It is the quantitative science based on measurement. So physics is a subject of measurement. When I measure, I get a quantity, I get a value, a count, a magnitude. So the quantity, it is associated with a proper unit. So this is termed as physical quantity. You know, physical quantity is perfectly defined as, it is a physical aspect around our natural thing. Any physical aspect which can be defined, which can be measured either directly or indirectly, and which is used to express the basic laws of physics. So physical quantity, it is the measured value of any physical aspect which we come across around us. You know, so physical quantities, based on their orientation, they are classified into various two categories, actually three categories. Well, the third one is of higher knowledge. We come across in the higher on keen perception of the thing. So, for our convenience, for our level here, these physical quantities are classified into two: scalars and vectors. Now, why scalars and why vectors? Let us understand. You know, as the people studied, as the people researched regarding various quantities, they found the physical quantities, they have measured the values. As they moved on, now they have come across such physical quantities where the magnitude of the quantity depends on their orientation. Let me give a simple example. You see, when I stretch my hand like this, the shadow of the hand due to the light source on the board, you see the length of the shadow. The length of the shadow is now, when my hand is in this orientation, the length of the shadow is same as the length of the hand. But as I tilt my hand like this, as I move my hand like this, the length of the shadow on the board is reduced, decreasing. So as the orientation of this is changing, the magnitude is changing. So people have come across such physical quantities whose magnitude depends on orientation. Then people have found the necessity of categorization based on their orientation. So based on the direction, the physical quantities are classified into two, right? So physical quantities are classified into two. They are scalars and vectors. So our topic today is vectors. Now, why vectors actually, you know? So I was telling you, physics is a subject of measurement. You need to take measurements, you need to use some mathematical operations. We apply algebra, trigonometry, calculus, all that. And you have studied these things in your earlier classes, but this vectors, it is new to you. So I wanted to give you a basic tool required to understand the various physical quantities in physics. Most of the physical quantities are expressed in terms of direction. So vectors is a very basic mathematical tool which is required to measure the physical quantities. So our topic is vectors. Now, so physical quantities are classified into two, scalars and vectors. So what are scalars? Let us have a keen perception regarding this. A scalar, the word itself means it is just scaled. Scaled is to measure, it is just measured. So the quantities which are just measured, and they have got a magnitude. When you measure, you get a magnitude, and it is associated with a proper unit to it, which possess only magnitude and they have got no direction. You know, sometimes scalars even possess direction. Even if they possess direction, this direction has got no significance, no importance. It doesn't influence the magnitude of the scalar. So simply, scalars are physical quantities which possess magnitude and insignificant direction, if so. They are expressed, so they are just simply, they possess magnitude, right? And these scalars, they are expressed by mere numbers, like for example, mass of a body, mass. So mass is expressed by a mere number and a proper unit associated to it. The quantity is 10, the value, the count is 10, and the unit is kg. It has got no direction. So even if there is direction, it has got no importance. So they are expressed by just a mere number and a proper unit. There are some scalar quantities which even possess direction also, right? They are called, just simply termed as directional scalars. For example, electric current I, electric current. So when you consider a conductor, current is flowing from this end to that end, so there is a direction specified for it, but the direction has got nothing to do with the magnitude. It doesn't influence the magnitude, right? Velocity of light even possesses the direction. Electric current, velocity of light, pressure, surface tension, these scalar quantities possess direction. But their direction is of no importance, no significance, right? So there are some directional scalars which have magnitude, unit, and even there is some direction specified, but direction is only according to their convention. It's not based on the thing there. Now, these scalars can be positive, they can be negative even. Positive and negative. Example, charge, electric charge, positive charge, negative charge. It is only by convention, right? According to the convention, they are positive and there are negative values. Negative values can be obtained first, right? Now, so scalar quantities are those quantities which possess only magnitude, right? They do not possess direction. Even if they possess direction, it is of no significance. They are expressed by a letter. Just a letter represents the physical quantity, scalar quantities. They are expressed by a value, magnitude, and a proper unit associated to it. They have got no direction. Even if there is direction, it has got no importance. Why? Scalars have same magnitude in all directions. The conductor, the electric conductor, current, carrying current, the magnitude of the current flowing through it does not vary with the direction there. So even if I orient the conductor this way or this way, there is no variation. There is no variation. So it does not depend on this. Even if they possess direction, they do not obey the laws of vectors, rules of vectors. If a quantity has to be a vector quantity, it has to obey the laws of vector addition. There are some rules to be obeyed. So scalar quantities, even if they possess direction, they do not obey the laws of vectors, right? They do not obey. Hence, they are just named as scalars. They can be positive, they can be negative, according to their convention, right? So they can even possess direction. Direction is just for simple convention there, okay? Now, the directional scalars, even if they possess direction, in all directions they have same magnitude. So scalars have same magnitude in all directions. Their magnitude does not differ with direction, right? And these scalar quantities, right, can be positive and negative. Example, when I take some examples, it's mass, length, time, so on and so forth, work, energy, etc., heat, all that, right? Some directional scalars, some quantities which possess even direction. So some directional scalars, you can remember them as, right, electric current, right, pressure, surface tension T, surface tension, right, they possess direction, but their direction is of no significance, right? And these scalar quantities, they are manipulated by ordinary algebraic methods, right? They are the addition of scalars, subtraction, multiplication, division, they are carried out by ordinary algebra. And when you manipulate these scalar quantities, you yield scalar quantities only. So scalars on manipulation, mathematical operations, when you perform mathematical operations, they yield scalars, right? So these scalars, they yield scalars, they obey ordinary rules of maths, algebraic mathematics. Now coming to vectors. So I was telling you why the classification has come into picture, because the people have noticed that there are certain physical quantities whose magnitude differs with direction, their orientation. So based on that, they categorize the quantities. So vectors. Now what are vector quantities? Please consider. Vector quantities are those physical quantities which possess magnitude, right? They possess magnitude associated with the proper unit, and there is a specified direction, significant direction, which has got proper importance, significance. So vector quantities are those quantities which possess magnitude and significant direction. Not just simply possessing direction, they even obey the laws of vectorization. So they obey the laws of vectorization, rules of vector. Rules of vector addition. You know, scalars may possess direction. They have got magnitude. Some scalars do possess direction, but they do not obey the laws of vector addition. Hence, they are not categorized into vectors. They are put as scalars. But those physical quantities which possess magnitude and significant direction, right? Those quantities are called as vector quantities, and they obey the laws of vector addition. Right? So examples for it, examples are displacement, velocity, acceleration, force, so on and so forth. There are many vectors we come across. In physics, most of the physical quantities are based on these vector analysis. And you know, these vectors are associated with the direction, so they cannot be manipulated. So you cannot operate the addition. Combine vectors by ordinary algebraic methods. So they are combined by an additional mathematics called vector algebra. So there are certain rules to be followed to combine them, right? So therefore, vector quantities are those quantities which possess magnitude and significant direction, and which obey the rules of vectors, the laws of vector addition. Examples are like displacement, velocity, displacement, acceleration, force, impulse, momentum, so on and so forth. Right? Next, representation. How do you represent the vector and scalar quantities? So I was telling you, scalars are represented by a letter. Suppose if I take time is represented as t, the quantity is 30 seconds. So they have got a mere number and a unit to express. There is no direction being specified. But coming to vector quantity, now how do you represent a vector? Representation of vector is by three methods. There are three methods of representation of vector. First, pictorial representation. Pictorial representation of vector. You represent by a diagram representation of vector. Pictorial representation of vector. Second one is the mathematical representation of vectors. Right? So mathematically we represent mathematical representation of vectors. And the third is by polar coordinate method. We even represent vectors by polar coordinates also. There are three ways of representing the vectors. So let us understand keenly regarding these things. So first, pictorial representation of vector. How do you represent a vector? You know, if there is a vector, let's say force. A vector is represented by a letter with a bar over it, showing an arrow like this. Usually in books they show it as bold letters, or well, bold letters, sometimes it is, you can see it clearly, probably or not. So it's better to represent like this. The vector quantity is represented by a letter with an arrow over it. This is the symbol that is given to a vector, right? Every vector has got a magnitude 10 newtons magnitude, and a unit, proper unit associated to it, and there is direction that is specified. Let's suppose there is a force of 10 Newton acting along east. So force 10 Newton acting along east direction, east. So this has to be represented. Now how do you represent? A vector is represented by a line segment. A vector is represented by a line segment with an arrowhead. With an arrowhead like this. The initial point, this is the starting point, initial point, origin of the vector. The initial point of the vector, tail of the vector, and this is the head or the terminal point of the vector, arrowhead of the vector, right? So a vector is, by diagram, graphically it is represented by a line segment like this with an arrow. Now what does this represent? The length of the arrow, this length of the arrow represents the magnitude of the vector. So what do I mean magnitude of the vector? Suppose if I have to express a vector, let's say force, a force of 250 newtons, a force of 250 newtons oriented along, let us say, northeast direction, along northeast direction. You know, I have been telling you that the vector is associated with the direction. So what direction they are actually associated with? What direction we infer to it? Usually in our environment, in our conventional thing, we have specified 6 different directions: east, west, north, south, up, down. So with respect to me, this is east, west, north, south, up, down. These are the 6 defined directions in our environment. We consider those directions only, and we put them into the orientation. We put them mathematically and this way. Suppose here, let me represent the direction. Suppose if this is, I am representing, this is east direction, and this is west. According to on the plane sheet here, this is east, this is west, north and south direction. This is north and south. So our direction, so this is the thing I am representing. So this is our convention in this on this plane sheet, right? So that is east and north. Now 250 newtons is the magnitude which I have to express. You know, you have studied in your earlier classes, while drawing a graph, you were taking a scale where you were representing the physical quantities on the graph based on the scale. So there was a scale that is being observed. Every 1 unit in your graph represents certain fixed quantity. So similarly here also what I consider is, actually the force what I have to express is 250 Newton. What I do is, I consider according to the scale here, 1 unit of length in this diagram, 1 unit I shall consider it as 15 newtons. So as per my diagram here, 1 unit length in this diagram is equivalent to 50 units. That is my scaling, my representative, my convention. So 1 unit of the length is equal to 50 newtons. So I have to express 250 newtons. 250 units is 5 units of 250 newtons is 5 units of this length. So I draw a line segment of 5 units length. So this is 5 units of length. Well, according to this orientation, if I picturize here, then according to this orientation, this is east direction and this is north direction. Well, I have to express the vector 250 newtons along northeast. So this is east and north. Northeast is the direction equally inclined to both east and north. So equally inclined. So this is 90 degrees. So 45 here and 45 here. It is equally inclined, represented like this. So this is one of the way of representing the vector by a diagram, graphical method, picture method, the pictorial representation of a vector. A vector is always represented by a line segment, right? A line segment, its initial point, this is the origin, the head, the tail of the vector, and the ending point, this is terminal point called the head. This is arrow head. This arrow represents the direction from which point to which touch point it is oscillating, it is moving upon. And similarly, the magnitude is represented by scaling. I consider the scale as per my convention. 1 unit of length of my any line segment, 1 unit of its length is equal to 50 newtons. That is my convention. So I draw a line segment of 5 units, which is equal to 250 newtons. And the direction is east and north, so it is north. So this is the first way of representation of vector, diagram method, pictorial representation of vector. So any vector is represented by a line segment with an arrow. Arrow represents the direction going from initial point to final point. So this is first method. The second method is mathematical method. There is even a third method called the polar method of representing the vector quantity. Yes, so I was telling you, so first method of representing the vector is the pictorial representation of the vector. The second one is mathematical representation. How do you express the vector mathematically? Actually, to express mathematically, a system has been developed by Cartesian method. There is a Cartesian method by which a system is Cartesian system of representation. So what this Cartesian method has evaluated is like, he has converted this direction east, he has considered this by a unit vector I cap. He has converted the direction east by a unit vector I cap. It is positive x-axis, right? The direction, west direction is now opposite to x-axis, so this is positive x-axis, right? And the opposite direction, that is minus x-axis, he has denoted it as minus I cap. So what in this representation, what is being conveyed is a new system is developed, a Cartesian system. Cartesian has developed a new system where he has converted certain unit vectors denoting some fixed directions, like east direction, positive x direction, he has denoted it as I cap. It's a unit vector. A unit vector is the one which is of 1 unit magnitude and a specified direction. It is having a specific direction. So unit vector along positive x direction is represented as I cap. Unit vector along negative x direction, that is, in our terms it is west direction, it is minus I cap. Similarly, unit vector along y direction is plus g. Unit vector along north, this is actually north, positive y direction, positive y axis, right, he has converted as plus g. Unit vector along south, right, this way, well I am denoting here, it is like this as south. So this is south, north south, this is minus j, minus j. And unit vector in the outward normal to the plane, outward normal to the plane, the direction perpendicular to the plane coming out, that is positive z direction. Now this is converted as plus kk. And the direction into the board, into the plane of the board, where I cannot represent on the board, it's a two-dimensional plane, where I cannot represent the third dimension. But you please imagine the third dimension, that is the direction normally out to the plane of the board, coming out from the plane of the board. Now that is taken as plus k, it is z axis plus z. Well, the direction into the plane of the board, plane of the surface, right, that is taken as minus k. So he has symbolized these vectors by some unit vectors. For positive x-axis, it is plus I cap. For negative x-axis, minus I cap. So in our original orientation, positive x-axis means east, negative x-axis means west. Now positive y-axis, it is north, positive z-axis, positive y-axis is north, negative y-axis is south. So this he has symbolized as plus j and this is minus j. The direction outward normal is plus k, the direction into the board is minus k. So now he has given some mathematical symbols to denote the direction. Now if I have to represent a vector of magnitude, say, let us say some 250 along northeast direction, its a shadow here and its a shadow here. Let's suppose this is a vector some capital A bar. Its a shadow on x-axis. Let the length of this vector along x-axis, its component along x-axis, it is A. The magnitude is A. Well, it's a shadow on y-axis. The component on y is B. Now I represent the vector A bar as it is A units along positive x-axis. So A units along positive x-axis, which is symbolized as plus I cap. So I represent the vector A cap as A I cap. And it is B units along y-axis. So it is A units along positive x-axis and B units along positive y-axis. So it is plus B units along. I have symbolized the vector along positive y-axis as J. Like this. This is the mathematical representation of the vector. Vector represented mathematically like this. So what do you spell? What does this spell out? When I enlarge this, when I expand, a vector A bar is A units along the positive x-axis, that is east, plus the B units along positive y direction. You can understand this way. So it is AI plus BJ. This is actually the position vector. It's actually represented as position vector. Well, we'll have a keen study about this later. So I just wanted to make you know, how do you represent a vector? A vector can be firstly by a diagram, graphical method, pictorial representation. So a vector is represented by an arrow, a line segment showing an arrowhead. This is initial point, that is terminal point, right? This is terminal point, this is initial point. The tail and this is head, this is arrowhead. Well, the direction represents the direction of the vector. The length of the line segment gives you the magnitude of the vector, right? So that is diagram method, picture method. This is the mathematical method. For this, there are certain symbols that are being associated, that are being symbolized. So first you have to know the symbols, later you represent this. So this is the second method of representation. And the third method of representation is polar method, right? By polar coordinate method. Suppose there is a vector of certain magnitude, right? It's making a certain angle theta with a reference line. So this is the reference line, the line of reference. With respect to the reference line, it need not be in this direction only. The reference line can be in any direction. This can be a reference line, the vector can be like this. So with respect to our reference line, for example, if I consider this as an inclined plane, with respect to our reference line, the vector is making an angle theta taken in anti-clockwise direction, this angle theta. Well, and the vector is of magnitude, let us say this is of magnitude some small a. So the vector, this is actually a vector A bar, it is of magnitude small a newtons, some a newtons. Then by polar method you can represent the vector A bar as A its magnitude bracket the angle theta. So this is polar coordinate method. The first letter represents its magnitude and the second one represents the angle made by the vector with respect to the reference line taken in anti-clockwise direction. So that way you represent the vector. There are three methods of representation of the vector there. First is pictorial method, second one is mathematical method, the third one is the polar coordinate method, polar method of representation, right? This is the vector, it is actually a vector A bar, which is making an angle theta with the reference line. So here, while representing by polar method, you should have a reference line. It can be in any direction, it is according to your convention. So according to your way, whichever way, suppose if I consider an inclined plane like this, so this is our reference line. Our vector is like this. So with respect to the reference line, the angle is making an angle theta. So this is A bar. So I write A bar as A. The first one represents its magnitude and the second represents the angle taken in anti-clockwise direction. So this way I represent a vector. Okay, so vector representation of the vector is by 3 methods. So I was telling you, physical quantity, physics is a subjective, it is a quantitative subject, measurement, based on the measurement. So when there is quantitative analysis, there is measurement, there is a value. So I get a quantity, physical quantity. Physical quantity is any aspect which can be defined and can be measured either directly or indirectly, and which is used to express the laws of physics. So these physical quantities are categorized into 2, scalars and vectors. Scalars, which are just scaled, which have got only magnitude, no direction. Even if they possess direction, that direction has got no significance. They are just a mere number and a proper unit. Even sometimes scalars need not possess a magnitude, unit also. There are some scalars which possess only the value, no unit. Like for example, relative density or specific gravity. Relative density or specific gravity. Relative density of a substance, it is something like 8. Or refractive index of a medium, it is 1.5. Coefficient of friction mu 0.6, so on and so forth. They only possess value, they do not possess the unit even. Of course, they have no direction. Even if there is direction has got no significance. Now coming to vectors, let us understand. Vector is a physical quantity which possesses magnitude and a significant direction, which also obeys the laws of vector addition. So it should possess magnitude, it should possess specific direction, significant direction, and it should obey the laws of vectors. Vector possess unique magnitude in unique direction. If the direction is changed, its component changes. Its value in different directions is different. Right? Their magnitude changes in direction. So I was showing you, as I bend my hand like this, if you look at the shadow, the length of the shadow changes as the orientation of the hand changes, the magnitude of the shadow is changing. So vectors, magnitude of the vector depends on direction. Hence, while manipulating, combining vectors, even direction is also taken into consideration. So we cannot combine vectors by ordinary mathematics, ordinary algebra. So there is a separate algebra called vector algebra, by which we combine. So when we manipulate, we get vectors. When vectors are manipulated, we get vectors and scalars. So that we will be studying later on, right? So coming to the next part of this. So first vectors, representation of vectors. Next, we have to study about the types of vectors. What are the various types of vectors? We should know the various types of vectors that are being categorized. How vectors are being classified, how they are being separated, classified, categorized, the types of vectors. Firstly, the vectors are classified into 2. Simple, real and virtual. Real vector, right? Real vector or polar vector. The other one is virtual vector, pseudo vector or non-polar vectors. So based on their existence, the significance of existence, they are categorized into 2: real vectors and pseudo vectors, or virtual vectors, pseudo vectors, virtual vectors, fictitious vectors, right? They are categorized into 2. Now, what do you mean real vectors and pseudo vectors? Right? Classification based on the vectors. Now, I was telling you the representation of the vectors. Even there is classification based on the representation also. Right? All that we will study. So, firstly, the vectors are classified into 2. They are real vectors and pseudo vectors. Now, what are real vectors? Real vectors are those vectors which are represented, right? They are represented by the convention in circumvention. Yes. So vectors are classified based on their orientation as real and pseudo vectors. Real vectors, those vectors which are represented, which have real value of existence, which are represented by a coordinate system, and they do not change based on the frame of reference. They do not change based on the frame of reference, and they really exist. But their direction is being convented. They possess their direction originally. But pseudo vectors, the direction is convented to it. The direction is convented. Their direction is represented by right hand thumb rule. So we express by some certain rules. So based on that we classify the vectors. Real vectors and pseudo vectors. Examples for real vectors are displacement, velocity, acceleration, momentum. For this pseudo vectors, they are rotational vectors. Pseudo vectors, virtual vectors, right? Fictitious vectors, they are angular velocity, angular acceleration, angular momentum, torque, couple, etc., etc. Their orientation depends upon the frame of reference. Their direction is being convented, right? They are localized. Actually, they pass through the axis of rotation. They are rotational vectors. We come across such vectors in rotational motion. These vectors we come across in translated motion. They are rotational vectors, right? And their direction lies along the axis of rotation. They are also termed as axial vectors. Axial vectors, rotational vectors. Their direction is represented by right hand thumb rule like this. There is a convention, and they are fixed. They are localized. They pass through the axis. They cannot be displaced. Vectors have a simple thing. If there is a vector represented, when the vector is displaced parallel to it, if I displace the vector parallelly in this direction, or if I displace the vector parallelly this way, right, there is no change in its orientation, its magnitude, direction, everything remains same. This way, I can freely displace the vector in any direction this way. Such vectors are free to represent. They are free vectors, right? But these vectors, they cannot be displaced to whichever point you can displace. They are localized. They pass through the axis of rotation. Localized vectors, right? You come across such vectors in rotation. They are called rotational vectors. They're pseudo vectors, rotational vectors, and their axis. These direction of these vectors, when the body is rotating, the direction passes through the axis. They are called as axial vectors. Their orientation depends upon the frame of reference. So these vectors, real vectors, they exist really. Practically, you can sense them. And these vectors, they are independent of the frame of reference. Whatever you consider the frame of reference, their orientation does not differ. Like for example, if I have to represent a vector, if I consider this room as a frame of reference, considering a point as an origin, I represent, then the vector is represented in this form. This real vector remains the same even if I take another frame of reference. Their orientation does not change. But for pseudo vectors, their orientation changes when I take right hand system and left hand system. For right hand system and left hand system, their orientation differs. So it is convented, it's not real. Pseudo, they are not real, they are virtual. Pseudo vectors, virtual vectors, real rotational vectors, axial vectors, and they are limited. You come across this only in rotational motion. And here we come across this in translated motion. So first classification is based on the orientation of the vectors. Similarly, these vectors are classified, right? So when the vectors are, there are two vectors whose direction is same but the magnitude is different. If there are vectors represented, there are two vectors A bar and B bar, right? Their direction is same but the magnitude is different. You see, the length of the element is different, so the magnitude is different but the direction is same. Such vectors are called as like vectors, parallel vectors, right? They are in same direction. Like vectors are parallel vectors, so they have same direction but the magnitude is different. Now similarly, suppose if there are vectors, their magnitude is different and the direction is opposite, right? They are anti-parallel, 180 degrees. Here both are in same direction, the angle between them is 0, theta 0. But here they are in opposite direction, theta 180 degrees. Now they are anti-parallel. Such vectors are called unlike vectors. They are unlike vectors. So this way, based on the orientation, based on their representation, their direction, their magnitude, their association, their linkage, the vectors are classified into various types, right? So let us review back what we have studied for today, is it? So I was telling you, science is the study, science is to know knowledge. It is the systematic and the organized knowledge of the physical phenomena around us, or natural phenomena. It's an organized and systematic knowledge of the natural phenomena around us. Physics is a category of natural science. Physics deals with the study, it is the quantitative study based on, quantitative knowledge based on measurement. Study of measurement. Physics is a study of measurement. We measure. When we measure, we get a quantity. What we evaluate, what you deduce when you measure is physical quantity. You know, physical quantities are those which can be defined, which can be measured, defined, measured. You can measure directly or indirectly, and which are used to explain the laws of physics. So now, based on their orientation and dependence on the direction, they are classified into two. Scalars, vectors. Well, third time we will talk about this later. Scalars and vectors. Scalars, they are just scaled, measured, right? So they only possess, they measure, they possess magnitude, they have no direction. Even if they possess direction, it has got no significance. They are just represented by a mere number and a proper unit. But vectors have both magnitude, direction, significant direction, and they obey the laws of vectors. Scalars, even if they possess direction, they do not obey the laws of vectors. Right? Vectors are those which possess magnitude, direction, and which obey the laws of vector addition. Right? So vectors, example for vectors: displacement, velocity, acceleration, momentum, force, etc., etc. Scalars, there are some scalars which even possess direction, simply called as direction scalars, but they possess direction, they have got no significance. Scalars, even though they are mere numbers, they can be positive, negative also, according to convention. Vectors, they are represented by a proper magnitude, proper unit, and the direction. Now, how do you represent a vector? There are three methods of representing vector: pictorial method, mathematical method, and polar method. Three ways you can represent a vector. Then we were studying types of vectors. So we will have a clear study of types of vectors today. Thank you.